This conference will now be recorded.
Okay, so today's session is about Kubernetes, and we'll be focusing on EKS, right? I've taken EKS managed service, so therein we are going to see how we can build a cluster and how we can, deploy some service, and how we can scale the service, how we can upgrade the cluster. So there are many things to it. So this is gonna I mean, we have to focus. We have to follow along. And if you have any doubts, please ask me. So there are many things I'm going to cover today. So Kubernetes, as people who don't know, it's orchestration. So like this, there are many others we have, but most choosy or in industry-wise, if you look at people are using Kubernetes beat because it offers many things. It offers you have open source, you can install in bare metal, you can install in, you can have managed service like even GCP offered is Azure offer it, Amazon offer it. So whatever, like based on the company which you are working, you might based on the business decisions, they would pick up each one and they would use it. So it offers, as I said, why people are switching to Kubernetes because it offers you can install it in bare metal, you can install it in your VMs, you can install it in Docker, you can anywhere you can install it. So that is whereas if you take other services like ECS, Amazon Container Service, or maybe OpenStack or OpenShift, those things are like kind of proprietary or managed services where you cannot install it in your on-prem, or you cannot install it in a bare metal server, or you cannot install it anywhere else. So that is the reason people are getting towards more inclined towards Kubernetes and what things offer. So you can integrate a number of open source tool inside this. You can have many things. So that is the main reason why people are switching, or I would say try more inclined towards Kubernetes. So today's topic is, as I said, we're going to talk about EKS. Specific to EKS, it's Kubernetes, but it's managed one by the EKS. I mean Amazon. So there we are going to see the tool. This is the pictorial representation that I'm going to explain today. So before get down to the demo of that, let me talk about this. What all things we are going to cover and how it would look like when I'm trying to when I'm saying that. So EKS-CTL would be the tool that I'm going to use. So you can build your infra, or you can build your cluster via Terraform. You can build your cluster via EKS-CTL. You can build your cluster via AWS CLI. So I picked up EKS-CTL because it has good feature. I mean, it improved a lot over the time. When I used it earlier, it did not have that much feature, but right now, when I was doing some test around this, I could see it is very good. You can do anything out of this EKS-CTL, and moreover, now it was open source earlier, but now Amazon has adopted it, and the integration with the EKS with EKCTL is very good now. So anyway, you will see it as I demo it uh, as we go on, right? So then we will create a EKS cluster out of it using EKCTL, and then we have a Jenkins. Again, the Jenkins I'm using to build and deploy, not deploy as such. What I will do is in Jenkins, I'm using it for building image, right? So the image I'm going to deploy in the Kubernetes. So that image I'm building here. And second thing is Docker is anyway like all the containers would run in Docker behind the scene, right? So Docker is important. That's what. And then we have metric servers. And then what is metric servers? So metric servers is used to kind of get the stats like what the memory CPU utilization at the node level, or at the pod level, at the service level, all those things. That is why we're using metric servers. And then ALB ingress. So ingress, uh, people who don't know Ingress, so it sits in between the application load balancer and service, Kubernetes service. So it's kind of it mediates between them. So application load balancer, if we'll see it in demo again, but I'm just giving a brief understanding of what it is. So if you hit your load balancer, right? So that goes to the ingress, and based on the ingress rule, it gets passed on to the service, Kubernetes services. We'll see it. And then deployment, we are going to do deployments, we're going to do service, we're going to do pods, all those things we'll see it. So we'll deploy and then we'll do first we'll deploy it, then we'll create a service out of it, then anyway, if you do a deployment, that will get a pod, right? So we'll do that, and then we'll see blue-green deployments. We'll see rolling updates. We'll see. So say we have a say for instance, I'm going to deploy an version of image like blue v1, right? And then what I'll do is I'll do a rolling update on that, and then I'll deploy a green image, and I'll do rolling update there, and then I will gradually switching the traffic from one live. I will show it live, like I'll be switching traffic from one blue to green, something like that, right? And then we have cluster auto scaling. Cluster auto scaling, these two concepts are very important: cluster auto scaling and pod auto scaling. Why? Because say for instance, we have started your cluster with one node, right? And now there's a request to increase the pod count or the deployment count, the replica set to, say you were running 2 replica, now you're running 10 replica, right? So it cannot accommodate, the existing cluster cannot accommodate. So it should auto scale based on what requests are coming. So automatically the new node will get added to your node group, and that's how that all the pending pods which will be there, that will get pushed to the new node which would come as a part of the cluster auto scaling. We'll see that again. And pod auto scaling, what it does, say a pod means deployment creates pods, right? So and then you map the deployment with the services, right? The service. So what happens, say for instance at the service level, when you're hitting a particular endpoint, right? And the endpoint, while trying to access it, uh, so you get a bottleneck there. The utilization is very high, and the end users are complaining about, I'm not able to access. So what then the pod auto scaling come to play. What it does, it checks the memory and CPU utilizations of your at service level, at deployment level, and then automatically it scales. It adds multiple pods, like an additional pod. So a pod, it is like pod auto scaling, nothing but there's a terminology we call it as HPA, horizontal pod auto scaling, and there is something called vertical pod auto scaling. So horizontal pod auto scaling is nothing but it adds similar pod, like say for instance you have a pod of 500 which is assigned with 500 MB of memory, so it will add another pod with 500 MB, it will add another pod with 500 MB. Whereas I'm not going to explain the HPA because this again is very much too much thing we are going to see today. So you have to follow along what I mean as I go on, as I show in demo. So and horizontal, I'm just explaining what it is. So horizontal pod auto scaling is nothing but you'll have a pod. Say you have configured a pod with 500 MB. So that would create if you configure vertical pod auto scaling. So what it does, it adds, like it increase the size of it. The from based on the utilizations, it like 500 MB. It will increase the size to the maybe 1 GB or whatever the size it needs. So that again, it's not out of today's topic. We'll see it another day. There are many things, pods, but to start with, these are the important concepts in general industry wise. You will see people are using it, and then we'll try to see the rollback of deployment. So for instance, you've deployed something, right? And you have deployed something, say version 1.1, and now the version had some issue. So how can you roll back? So how can you fall back to the previous version without any downtime? So that also we are going to see today. And then finally, the important thing is we are going to see the entire cluster upgrade. So how do you do a cluster upgrades, right? So that is very important concept without any downtime. So say you're in version 1.21, how do you upgrade to 1.22 or any later version which is new, right? And your team or your management has asked you to do. So how do you do it, given that you are not disturbing the existing things? Every existing thing should be intact. There should not be disturbance with that. So how do you do it? That is very important. So we're going to see that as well. So there are many things we are going to discuss. So please follow along. I will let you guys ask questions in between as I go on. But I will request again, please don't unmute yourself until I ask you. Okay, so let's get down to them. I hope uh, this is pretty clear that what we are going to talk about. If you have any doubt, please ask before I get down to the demo part. Anyone can ask now. Anyone have any question? You can ask. Otherwise, we'll get down to demo. No. Okay. Fine, I'll take this as no. So let's get down to demo. Okay, so what I have done here is what I had done just to save our time, what I did was I had created a cluster. Okay, so let me take you through that. So the config file I have used is this EKSCTL. This is the config file I have used, right? So the cluster name is demo EKS cluster. The region is US West 2, and the version is this availability zone. These are all the configurations I have kept here. So desired instance to manage group name is this, instance type this. I'm using spot instance just to save some bugs here. And then maximum it can grow up to 5, volume size, all these things, all these things. These are part of configurations. And this good thing is that I have kept all my things in my GitHub repo. So you can if someone needs it, all the codes are there in my GitHub repo. This is the GitHub repo. Kubernetes with EKCTL. So we can just follow along if you need it. So okay. So this is a cluster. So it is already set up because as it takes nearly 30 to 40 minutes, I had built it earlier before our session starts. So there's a simple command you can do it. So there's a script I've written. So the command is this EKCTL create cluster hyphen of this, and it creates a cluster for you, right? So just to see what I've done it. So and k get node. So k is like I've set aliases because I did not want to type kubectl again and again. So that is what I've made an aliases. So don't get confused what is k, right? So if you type aliases, you will see I have somewhere k equal to kubectl. Okay, so it's kubectl only, k aliases I have set it. So right now I have one node, right? Okay, so let me take you through what all things it does after the deployment. I mean, once I deploy this particular Kubernetes cluster. Okay, so let me take you through that. So first of all, if I go to EKS Kubernetes service, right? So there I will see demo EKS cluster, and it is of version 1.21, right? And then if you go here, if I go to compute, I will see it is created a node group of my node group, my node group, right? It is again version of 1.21, whatever, right? And then what extra things it is, it creates a VPC, it creates a subnet mask, it creates a security, everything it does. Okay. So if you see here, this is the previous one. This is the one it has created. EKSCTL demo EKS cluster, right? So this one it has created a VPC. And if you look at the subnets, it creates a subnets as well. So these are the subnet it has created. See here, demo. These all subnet it has created. Okay. And then it creates elastic IP, it creates everything, whatever the infrastructure, it creates everything behind the scene. So you just have to, it is very easy. That is what I was saying, like EKCTL is very good tool. You can use it to build a cluster without needing you to think about many things. Okay, so it does things for you. You can just work on your business logic. I mean to say, you can work on your actual deployment things and all. Need not to worry about how EKS is managing that. So this is very good tool you can use. And so this is also it does create the auto scaling group again behind the scenes. So if you come here, auto scaling group, you see here this auto scaling group is created with the node group. So this auto scaling group is created. It does create auto, but it creates each and everything which it needs to build a EKS cluster. Okay, so it does everything behind the scene. So we need not to do anything about that. So cluster is created, right? And there's one more thing. Let me show you. Okay. So what I've done before this call again, I built two images. Okay. So one image was this blue image, and that is pushed to the blue repo. I will show that again. And there was blue green. So blue and green, I've created two image before our call started. Green image with version v1. So let's see it where we have it image. So if I go to ECR, Amazon Container Registry, this is a repository that I've created earlier. Blue, if you see here, the tag is blue hyphen v1, right? And if I go to green, the tag is green hyphen v1. Okay. And now let's see. Now let's deploy. So this image will deploy. So I will go to deployment. So here I've created, let me just deploy, then I will explain. Cube apply -f blue. Okay, I'm deploying the service now, and then I'll show you, uh, and then I'm deploying a service now. Okay, so I'll take you through the files that whatever we have there. So let's go to the file now. So if you look at, this is the deployment of type. I'm running 2 replicas and then this match selector. Uh, this will be rolling updates. We'll do it. So this is the image, right? This is the image, blue v1. This is my image. I'm deploying it, and these are like I've started, like I've kept some resource limit and all those things, right? So nothing. So strategy. I'm not going to go and explain all the fields here, but the majorly let's talk about the images. Uh, so we are deploying blue image. Similar to that, if you go to green, you see here we are deploying green image, right? And it's on the port 80. This is important, port 80. And if you see here, we have a replica 2, okay, port 80 and image v1. So if you deploy an deployment, so behind the scene, what it does, it creates two pods, right? So if you see get pods, you will see two pod, blue 2, green 2, because we had in the deployment config we gave replica 2, so we have two pod, two green pod, right? So now service, we have deployed pods, or we have deployed two pods. Now how do we access these pods? For that we have to go to service. We have to create a service, right? So I have created service. So if I see here, let me just, I will explain that. Okay, blue service I'm creating, and then I will create green service. Okay, so you have a deployment, and as a result it has created two pods, right? Now your containers are running, but what is the use of it? If you're running it, you have to access it, like end user have will to access it, right? So for that, what we have done is we have created a service now, but this service is available within a Kubernetes cluster. You cannot access from outside world, but as you have to expose your service to the outside world, how do you do it? So there are two ways. One is you can create a service using load balancer, or you have an ingress controller, right? So I'm not going to do load balancer, and I'm going to focus on the ingress controller. So there's a difference between that. So we'll talk about it later. um, why I'm not using it, because we'll see it later on. Okay, so let's see it, how we are doing it. So now we have a service created. So if I go to service, uh, say describe service, it is pointing to a deployment. So it is pointing to blue target. Okay, so deployment name I did not. Okay, so an endpoint is this. So okay, let's look at the deployment name. So deployment name is, one is blue target, one is green target, right? So this service is, blue service is going to selector is blue target. It means it is pointing to blue deployments, and for the green service would go to green deployment. The important part I'll show you now. So it is going to green deployment. But if you see here endpoints, okay, so this IP address, look at this IP address. Endpoint, it says 94.179. So what are these IP addresses? So these IP addresses are nothing but the pod IP addresses. So deployment creates pods, and now you're pointing service to the deployments. Okay, so it's like it's like linking on together. So service will talk to deployment will talk to pods, like behind the scene deployment creates a pod. So you're getting, this is the pods IP. So let's see is it same, get pods, right? So the IP address is this. So what we have seen for green, we have this IP address. Let's cross check it. So say I've taken this IP. Okay, describe pod. Say I'm doing this pod. Let's see if it matches. Okay. If I go to IP address 94, the IP address is 94. If I go here to 94, get deploy, where is that service? Green service. Which one is this? Sorry, this bit confusing. Get pods, describe service, describe pod, say green. The IP address is 179. Okay, green pod IP address is 179. Let's describe service, green service. See, it is pointing to 179. So it is pointing to this container IP. So it means it's like kind of load balancing. We have two containers running. So it's load balancing between this, which on port 80, right? So now we have a service created, but it is, if you see the status, get service, it is internal. It is cluster IP. It is not external, right? It is not exposed. Now, how do we access this particular uh, service or particular container, particular your job or whatever, say your application? How do you access it? Okay, so to access it, we are going to create an ingress controller. We are going to create a ingress controller. Okay, so there's an ingress controller we have to create. So for that we have to have certain policy created. So I have automation script around that. I've created well in advance. So we'll go to it. So let me just run it first. I'm creating some policy around it and attaching to the node. So this will create some IAM policy and attach to the node group, which would help us in configuring the ALB. So this is creating a policy and attaching it to the load balancer. Sorry, attaching it to the node group. It is creating some target, all those things, custom resources it's creating. So we have done a deployment, which has created a pod. We have done service, which is mapped to deployment, right? And we have seen how service IP, how service are getting prod IP address. So it will get like mapped to the pod IP address directly. So when the request come, it directly forwards to the pods, respective pods. Let's please mute your. Okay, so get pods -a. If you see here, so there's AWS load balancer. It has created this pods. We need them. So now, what I'll do here is, if I go to ingress, okay, so I'm creating ingress controller now, blue, green, and it is pointing to blue service and green service. Let's do. So for now, if I go, guys, please mute. So for now, if I go here, if I see to the load balancer, there won't be anything. Okay, it's free, nothing. So now let me just apply this ingress and let's see what happens. The moment I apply it, it creates an application load balancer. and then that load balancer map services. Okay, let's see. Map service as a, it has created this, but its status is provisioning. Okay, so the important point here is two target groups. Okay, let me take you through that again. So what it is doing, it is pointing to, so target group, it creates a target group blue and green service. Okay, and it on the port 80. So currently I'm giving a weightage of 80. So green service will have 80. So I will talk about it, what it is. So if I go here, it is this, but if I go to target groups, I see here two target group it created. One is blue, one is green, right? The important thing is here, no, see it here. In the green, in green target, see, it is pointing to, directly pointing to the IP address of pod. This is very important. Directly it's pointing to 192 or 16. We have seen this 179, right? So it is pointing to the pod IP. Similar to, if you go to blue one, it is pointing to blue IP, blue pod IPs. So you can verify that. And if I do here, so blue, green, wait, right? Now, if I go to load balancer, let's see if it is available. It is still provisioning. Okay, let it provision. So once it is provisioned, then we'll try to access it. Okay, we'll try to access it once it is provisioned. Yes, it is active. So let's try to access it with this DNS name and see what we are getting. Okay, so I'm hitting some command in a while loop, and we'll have it running till we finish this session. While do curl sleep one done. See what it is doing. This application is up. My application is up, right? So we have done a deployment. We have done that creates a pod, and then we have mapped the deployment to the service. Service was not exposed to the outside world. To access that, what we have done was we have created an ingress controller. Now, ingress controller, what it did, it created an application load balancer. And application load balancer is pointing to two targets, right? Let's see here. So it is pointing to green. So I'll do something now. Say you have got two multiple version of running. So what I can do here is I'll go to listener. I will edit here. I will go here. Do this again. This can be done entirely automated, but I'm just to show you guys. I'm doing it manually. Only this part. Okay. So what I'm doing here currently, all traffic is going to green target. So what I'll do here is I will make green target 80% of traffic. This is nothing but a canary deployment, and we'll make it 20% go to the blue target. Okay. Let's see. 80% is going to green, 20% go to blue. Now let's see what happened here. So we should see in some time, few traffic should be blue target 1.0. Okay, and few and most of the app should be green, and but few should go to blue target because we have changed the model. See here, blue. It started going to blue. So 20% of traffic would go to blue, 80% of traffic will go to green target. So this is nothing but canary we are doing now. The changing of the percentage of traffic from one to another. That is canary deployment. Okay, we'll see the rolling updates and other things. Blue green, and blue green is nothing but these two we have done, right? Two services, one is blue, one is green. Now I'm routing traffic from 1 to 2, like blue to green. Okay, so let's do one more thing. Now it is 80%, right? So as a part of again canary, what I'll do here, I will complete, say now the customer says everything is fine. Now what I'll do, I'll make it 0, like nothing, everything is fine, right? So I'll make all the traffic to green now. So this I've completely switching from green target to blue target. Okay, so if I do here now, let's go here and let's see. We should not see green in some time. Everything should be blue now. So it takes some time, and then once it should be coming to all blue. See here, all blue started, right? So all our entire traffic is moved to blue now. So it means Now green deployment, we can do green deployment. Okay, we can update image for green and then move traffic all from blue to green. We'll see it in some time as a part of our deployment, right? So now the next thing is we'll go to the important concept here, this pod auto scaling and cluster auto scaling. We'll go to the deployment later because deployment is already done. The blue, green, other things we'll see it in some time. So let's go to pod auto scaling, cluster auto scaling. Okay. So for pod auto scaling, I will have this running. So in throughout an entire session, we'll have this running and see what is happening, whether it is everything is dropping or not. So because our intention is to have these completely automated, right? Without any downtime, we'll be doing everything. So let's for end user is doing this. Say for instance, our end user is accessing an application like this. Okay, let's assume it and let's do it. And then now what I'm going to do here is I'm going to deploy cluster autoscaler. Okay, so for that there is some script. Again, I did some automation around that just to save our time. I did this, so I'm going to run this ca policy.sh. What it is doing again, it is creating some policy and attaching it to the node group. Okay, this is needed because otherwise with our cluster cannot scale. So now okay, so there are two scripts I have to run. So what it is doing, it is doing a cluster auto scaling deployment. As I mean, it involves any manual thing to do, and so I did the automation around that just to save our time during the demo. Okay, so we got error, nothing to worry because let's see if the cluster auto scale is deployed or not. Yes, it is deployed. See, it is doing something. Okay, so our cluster auto scale is just to see it. Get pods -a. Okay, so before I jump on to the cluster autoscaler, I think I'm open for a question. You can ask me till now what we have covered. I've got 2 minutes. Anyone wish to ask anything? I've got 2 minutes. Please ask.
Yeah, I have a question. So, like, you ran this shell script before English, like what exactly it is doing this
Your voice,
very good manner.
voice is not clear. Sorry, your voice is not clear. I don't know.
So, before creation of ingress controller, you ran a shell script, right? So, what exactly the shell script is doing, and is that mandatory we have to
Yes,
run?
yes, yes. It creates a policy. It creates some policy. So generally, you have to do everything manually. What I did is I kind of encapsulate everything in a script and had it ready for me. Just to save our time. If I run it, it does things for me. Okay, you can do each and every command manually, copy and do it, but I did try to automate that and we did it.
So, we are trying to create some IAM roles or something to access
Yes, yes,
what it
yes,
is.
yeah. So that role it does. We have to attach it to the node group. Okay, so and without that, okay, so how does your EKS cluster would go and create a application load balance for you, right? It has to have some permission, isn't? So
Okay.
I added those permission so that when I deploy ingress controller, it goes and creates an auto scaling application load balancer for you. You need not to do anything,
Okay.
man. So for that
Okay.
it needs that access, right? So I had given that access to it.
Okay. So now you are giving Ingress to perform any creation of ALVs, target groups, and everything. For that, we are giving the time.
Sorry.
Now, for Ingress to create this ALV, we are giving those permissions to Ingress.
Exactly. Yes.
Okay.
Yes. 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 Those permissions.
And the Ingress is pointing to all the pods, right? And whereas if you see service is pointing to deployment and deployment is pointing to pods. Am I right
Yes.
in
Yes.
saying that?
Yes. Yes. Yes.
Hmm.
Okay. Yeah. Anyone else?
And
Anything?
then
Otherwise,
one final one. So metric server, like, can we see that also? Like, how are we
we'll
using?
we'll go to that, please. Let's not jump onto something which I haven't covered. Okay. this session is very rigorous one, so let's not, so if you have any other questions which I've covered so far, let's ask. Otherwise, let me jump on to another thing. Anyone else, anything?
Yeah, deployments talks with the service, service talks with ingress. Is it correct?
Yeah. So okay, so ingress sits between AWS and your service. Okay.
Okay. Okay,
So
ingress will used as to communicate between EKS and application load
yes,
balancer.
yes, yes. Application load balancers talk to ingress, ingress talk to service, service talk to deployment, deployment talks to pod. There are many, like these are the layers connected.
Oh, okay.
Okay.
Little bit confusion. Okay.
Any doubts there?
Shubham,
Yes.
yeah, in deployment.yml, we have seen the image name, right? In the which we have generated through Jenkins and uploaded through ECR. So
Yes.
is it like if you do new deployment and you get new deployments image updated to ECR? Last time we used the with the image tag v1, right? Is it
Yes.
automated like
No,
the
no.
latest?
This one I haven't automated. We'll do it manually.
Okay, okay.
We'll push it from there, but I'll do it. I'll change it manually here
In
because I have.
deployment YAML file, you will change the image name.
Yes, yes, and
Yeah.
I'll redeploy it again. Okay.
Okay. Yeah, got it. Thank you.
Okay. Okay. So let's go to cluster autoscaler. So this deployment is done. So how do you see it? Get pods -a. If you see it, you see it here. Cluster autoscaler. Yes, you have a pod running. Cluster autoscaler. Fine. So we have cluster autoscaler configured. Now let's go to horizontal pod autoscaler, which is very important. Okay, we'll see. So currently, if you see here, the you have only two blue, two green, right? Okay, so what if someone will simulate that again? What if someone you have n number of users accessing your server or accessing your application? So your pod should scale automatically. It should add more pods, right? Just to load balance between everything, just to save. End user should not get bad experience to that. So let's see. Let's see it in demo how it will auto scale. Okay, so for that we need to have two things. We will deploy metric servers. So there's again script I've created for that. So I am deploying metric servers now. Okay. So metric servers is used to collect the stats like memory, CPU utilizations from node or from pod, from everything I would say, like wherever we would use it. Okay. So metric servers. Let's see metric servers. Metric servers pending. This is one more pod is getting deployed in kube system namespace. Container is getting created. Okay. Maybe it's split by one. Okay, so meantime, let me just script review it. Take some time. Okay, so let me show you something here. We did ingress, right? Okay, HPA. So we'll create a HPA, horizontal pod autoscaler, for both the service, for both the deployment. Okay, so deployment is blue target. The deployment name was blue target and green target. Okay, so this HPA will connect to blue target and green target, but it will maintain minimum replica to maximum. It can scale up to 100. Okay, just to show the real demonstration. This is not in real time. You won't have this like 15% of CPU utilization, but just to demo like how it would behave. I have just kept it 12. Like if the pod or deployment utilization is more than 15%, then it will try to add more pod to it, right? So currently, let's do one thing. It's running, right? So what I will do here is just to see kubectl get pods -o wide. Okay. I'm like, just we'll see it. Okay, so it is C, 2 blue, 2 green are running. Okay, so we'll try to simulate something. What we'll simulate is we'll try to simulate a load test. So again, I have created some command around that. Okay, and I will try to simulate some load test just to see if our pods are scaling. So what we are accessing now, blue target, right? So our blue target should scale to n number. Let's see what it scaled to. So let me get the, okay, so what I can do here is ingress. If I do ingress, I will get the application load balancer ID. Okay, and now this is the command to do a load test. Okay, I'm just simulating the real-time load test. What if your end users are bombarding your things with this? So I'm doing it. And here, let's watch HPA. Okay, we didn't apply HPA, right? So, okay, apply FNF, blue HPA. So what it does, HPA, once you configured, it checks the deployment target. What is the utilizations of your pod CPU? What is the utilizations of green pod CPU, blue pod CPU? And then based on that, it takes an action if it reaches more than 15%. So as I said, what I kept here is 15% is the overall CPU utilization, right? So we'll see it now. Watch -n1 kubectl get HPA. See HPA. See this pod started. Did you see that? HPA. If you see the HPA, where the HPA? See here. It is adding pod. Earlier it was 2. It added one more pod. Let's see what happens. 22%. So 15%. It will add more pods here. Okay. So this is like real time. What I'm doing here is I'm bombarding things with some dummy request, like just to simulating real time what happens if you access your endpoints, more number of users, right? So I'm simulating that and sending the request. And what HPA is doing, it's checking, okay, is it more than 15%? Yes, it is more than 15%. It keeps on adding. See, it's increasing replica. How do you see it? You see it here. See, 64 seconds. Now see, blue, 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 blue. It keeps on increasing. And there's one more thing we'll see here. Okay, let's watch our node as well. Even node will go up. See, it added this node. This node again will go up. Okay, so by default it was one node. Now it has added 3 minutes again one node. This is again. So what is happening is behind the scene, your end user is bombarding your endpoint with something. So there are n number of requests. Okay, now cluster HPA checks that, and it found that it went beyond the 15% limit. Okay, and then what it does, it keeps on adding more pods. But if you have more pods running, where that would go, it will go in pending state. Okay, so that pending state, then autoscaler will come to play. It checks, okay, these many numbers of pods are pending state, so I have to go and add more instances. Then what it did, it went ahead and added more instances. See, 5 minutes ago it was update 67 minutes ago, just one, and now it has added one more node. Okay, if you keep on increasing, hello, if you keep on increasing, guys, please mute. If you keep on increasing the load, then it will go on and on and on. Okay,
నన్ను అంటావండి క్యాబ్ జర్నీ వాళ్ళకి అన్నాను కానీ
guys, please mute. Okay, so it will go on and on just to simulate the scaling. So let me just do something manually here. Okay, so get deploy. I'm going to scale number of pods manually here. So for the green pod, I'm going to do, for the blue pod, I'm going to scale it. So get kubectl scale deployment scale deploy hyphen hyphen. Let just to see how it is scaling our 20. Okay, we'll see if it is adding more nodes here just to accommodate that. So get pods. Where are pods? Okay, so there's HPA is enabled, right? So it won't let us go beyond that. Okay, so what is happening here is, if you see here, blue HPA, we have said max is minimum replica is 2 if the threshold is 15%. But if you see here, HPA utilization, it is 0%. There is no utilization. That is why it will not let us to, like if you scale also, it will come down to 2, minimum 2, because utilization is 15%. So unless you increase the load, it will not add more instances. Okay, so let's, so anyway, so what it did here, I think we have just seen. So the moment I added more, or the moment I gave more requests, I simulated more real-time things. So the overall HP utilizations went high, right? And then it added more pods, and it added more clusters. So we have seen both cluster auto scaling and horizontal pod auto scaling. Both happened simultaneously. So first, horizontal pod auto scaling, it adds more pods just to serve the traffic, more traffic. And when the pod went high, the number of pod went high, it could not deploy itself in any instance because there was only one instance running. Then what pod horizontal like cluster auto scaler, it saws it, and then it adds more instance to it, and then all the pods which were in the pending state got moved to, or got deployed to, or got pushed to in the new node which came in. Okay, so that is done, and let's see rolling. Let's see an update. Let's see an update. So we'll update the an image. So as we have moved, if you see here deployment, we are in green V1. Okay, so we'll change the deployment to V2 and see. Then what happened? We'll route all the traffic from green to blue to green. Now it is 1.0, right? So let's do that. Okay, so let me build the image. I'm building a new image now. Okay, so green V2 image name is I'm building, and ECR repo is green region EKS demo. This is green. I'm going to do a new deployment on green now. Okay, so 2.0 demo 2.0. I'm building it. That will get pushed to the ECR. Let's see the logs. Image build is happening. Green V2, and it pushed. Okay, so now let's go to the deployment and change the deployment config for green. Okay, so what I'll do here is I will do V2, and now apply. So I'm updating, like doing a new deployment for the green. Okay, if you see here, the green target will go off. See, it's terminating. Deployment is happening. New are coming. 8 second, 8 second. Okay, so previous targets were gone and new came in. Now if you see, go here, so we have got everything pointed to blue. Now go and change the setting rules. I'm going here again, I'm changing here. Let's first do 80% to blue. Just see, I'm doing canary again because we have done new deployment, right? So what I'm doing here, I'm just changing 20% of traffic to a new service that is deployed. green service and see if it is fine. The end user will confirm it's fine, yes, or maybe we can test. So we should see here, it should be green in some time, green 2.0. See, we got green 2.0, right? So deployment is successful. Now what we'll do, we'll move everything. So far we were running. So this is canary deployment we have done. So what we did a new deployment in green service. Then what we did, we moved the traffic from blue to green. Now after the 20% traffic is moved, we have confirmed this, everything is fine. Now we are going to move all the traffic to green. I'm going to do it again. Here, I'll make it 0, I'll make it 100, and then all the traffic to green. Okay, so let's see what happened. So everything should be in green in some time. Because our deployment was successful, we did everything in green. Okay, say for instance, we figured out, yes, this is not good. Say we figured out this new deployment was not good or it is not working after a day. Okay, so what we could do here is, we'll fall back to the previous deployment. We'll fall back to this because I had recorded. Okay, so we'll move to green again, back to 1.0 version with this command. So what we'll do here is, again, let me say we have green 2.0, we have moved all the traffic. Now it is something is not good and we want to move back to green 2.1, but blue service was previously running. Let's move all the traffic to green blue target and again roll back this one. Okay, so this one green, this one blue. Okay, again I'm moving all the traffic to blue. Okay, we should see blue. So we have green running from last 3 minutes. Again, I will do revert the changes that I have done. See, we have all the blue 1.0. Right now, I will revert the change that we have done. So roll out, undo, deployment. Green target -2 version 2. -2 versions. Roll out, undo, deployment -2 revision. Sorry. I've changed to, oh, sorry, it should be 1 then. Let's see what happened here. Okay, so there was no change, it should be 1. Sorry, my mistake. Yeah, it's all back. It should getting created. So we were seeing traffic green was 2.0, right? Now if I move the traffic to green again, I should see 1.0. Say blue 80% again, and traffic is 20%. If I do here, oh, there's a outage, little outage. Blue, now I should see a green 20%. Yeah, green is running fine. Oh, yes, so we have 2 outage, little outage, 1 second. So we have green back to 1.0, right? So we have rolled back the changes. We have rolled back the deployment. So this is fine. Now let's get down to the final thing. I know it's little we are going beyond our timing, but that's fine. The final is cluster upgrade will do. Okay. So what is the current version of kubectl we are using? Like current version of Kubernetes we are using. So we can do kube version -- short. It is 1.21. Okay. Let's update it to 1.22. Okay. So because in Kubernetes it is saying to update to 1.22. How do you see it? If you go here, if you go to Kubernetes demo cluster, it says update now. Okay, so it will go to 1.22. So let's see it. I have some script ready for that, so you can find those script again in my GitHub repo here. These are the scripts. So there are certain things we have. I have to. These are the command to upgrade cluster. There are many things involved. So what it involves many things. So we have to update node group. We have to update. Okay, so let me take you to the commands. So we have to update kubeproxy, we have to update AWS node, we have to update core DNS. So this again, everything will be taken care by EKS-CTL commands only. We need not to do anything manually. It's all again automated. So this is very good thing offered by EKS. This command EKS-CTL. So I'm going to use the same command EKS-CTL, and the cluster name I'm going to change it to demo cluster that I have, and what it does. See, my service is running. I'm not doing anything. Okay, so let's do everything to blue now, or maybe to green. I don't know what I did there. Let's do everything to blue. So blue 100%, or maybe green 100%, blue 0, green 100%. Okay, so you should see all green. That will come. And if you go here to the cluster upgrades, see what it says will be upgraded to current version 1.22, 1.21 to 1.22. So I'm doing a cluster upgrade now. This is a live upgrade I'm doing without doing anything, like without any downtime. My service is running here. End users are accessing. Let's assume this is end user, like I'm doing a curl command, but let's assume it is doing it. Okay, it's running version 1.0, so there is no problem with that. And now I'm updating the cluster. We have just seen the Kubernetes version again, just to see kube version -- short. It's 1.21. We'll see after upgrading are done. So there are many steps to it. First is this, and then we'll go with others. So this upgrade takes, this process take a bit of time, like 10 to 15 minutes of time, and I cannot help on that. I could not automate it because that is how it takes. It is updating the control plane servers in Kubernetes, and it takes nearly 10 to 15 minutes of time. We have to hold on to this, and meantime, let me just do some changes. Okay, I'm open for any question. Let this finish. It will take 10 minutes of time, so I'm open for any question. If you have anything, I can answer. I'll try to answer it. Anyone has any question while we upgrade this?
The flow which it's little bit confused is one. Can you give a rough flow which will
Okay.
communicate with?
Okay, sure. I'll do that. Yeah. Okay, so what I did, the first thing we did was we have deployed, like before our session started, we started, like I deployed the Kubernetes cluster, okay, and it was EKS cluster, and I have used this configuration to configure it, EKS, this configuration to configure it, right? And very after that, what I did a deployment, and for the deployment, I have used two files. Let me go there as well. I've used these two files, blue deployment, green deployment, because I had to create two services. And after the deployment, once you do deployment, it creates two pods each. Why it creates two pods? Because if you see here, I get two. I said two replica. Okay, so it creates two pods for each. And then what I did was I created service. If I go to service, again I see two things, two services are created, blue service, green service. Okay, so this service when I created this service will get linked to the deployment, and deployment get linked to the pod. So there are three layers to it, like these are interconnected. Okay, and now service, if you create by default, it is within the Kubernetes clusters. How do you access, like how do you make sure that the application they are hosting or that they have deployed will be accessible by the end user? Okay, so for that what I have done, okay, so there is no state answer to that, or there was no state solution to that. Then for that what I did is I have deployed ingress. So what ingress does, it maps AWS resources with the EKS resources, in the sense, like when you deploy ingress, it creates an AWS application load balancer. You can do many things. You can create application, you can create network. So load balancer. In my case, I've done application load balancer, and then what it did. Application load balancer will talk to ingress. Ingress would then talk to service. Service would talk to deployment. Deployment talk to pod. So if you create an ingress, okay, if you create an ingress, if I go to ingress, if you create ingress, then see I'm mapping the service, right? So in ingress, this is the configuration. Internet facing, this ALB, the ingress class is ALB, is like application load balancer, the internet facing, and this target type is IP. You guys have seen IP address, right? So if I go here, if I show you again the target group, so whatever IP you're seeing here, these IPs would be the container IPs. Directly it is pointing to the container IPs. So it means the ingress container talks to service. So service, anyway, you see here, if you describe the service, you are seeing, okay, get service, okay. If you describe the service, you will see, if you describe the service, you will see two IP addresses, right? These two IP addresses. This IP address will same, you will see it in here. Okay, this IP address will be same, you will see it in here. See here, 177, 188. If you see here, 177, 188. Okay, 480, 480. You see here, 480, 480. Okay, so ingress, then service, then deployment, then this. And then what we did was we did a horizontal pod autoscaler, and we did a cluster autoscaler. So horizontal pod autoscaler to work, we need a metric server. So why we need metric servers? Metric servers is to collect the stats between multiple resources. So how much pod is using, how much your node is using, how much other resources are using. We need metric servers. So for that we have deployed metric servers. Now cluster autoscaler. Okay, so now, so you have scaled your application to have 10 replica, right? And it tried to put those, it tried to start those containers. It went in what do you call pending state. Why it went in pending state? Because it will say no resource, no node to deploy this, right? And then cluster autoscaler will come to play. Cluster autoscaler check those things. It keeps on checking every few seconds or every few minutes. I don't remember the exact configuration there. So then what it does, it checks it, okay, these many pods are on a pending state. So it scales, it adds more pods, it adds more node to it. So how many nodes it can add? It can add these many nodes, the maximum size. This is important. So maximum size is 5. It can scale up to 5 nodes. You can keep it like 5, 10, 15, depend upon your configuration. So it can scales up to 5 nodes. So cluster autoscale, it keeps on adding node. It will keeps on adding node. And say for instance, if scale down the services, right, it will again delete those nodes. So you do not to do anything. This all will happen automatically behind the scene. You just have to do a configuration. Did that clear some of your doubts, or you still have?
No, now it's clear.
Okay. Anyone has anything while we have? This is. It will take 10 to 15 minutes of time. I cannot help, as I said, because I tried to automate as much as I could, but this.
If we try to implement the same, we can follow the same steps.
Exactly, yes,
Like,
exactly.
yeah.
I have kept all the configuration in my GitHub repository. I think I told already.
Okay.
So this is my GitHub repo. Okay. So we have got everything, all the configurations that I'm following for this demo. You can
Okay.
blindly follow that.
I think we have already this, or can you share with us GitHub repo?
And I mean, if you need it, I can share, but it is there in my repo.
That GitHub URL I want. I want to.
Sure. I'll share
Sure.
something.
Thank you.
Yeah. Anyone has any other doubts? I have time now because a cluster has to upgrade. No doubts? Good.
Hello, Shubham. Uh,
Yes.
so during the cluster upgrade, there is no downtime. The all services and pods are running it.
See, it is
Correct,
running,
no?
right? Yes, I'm actually see here.
Uh, yeah.
Everything is running, right? That is what the intention. Like, it is a live upgrade. There is no, see here, everything is running. See, 15 minutes, 24, 12 minutes. But I'm doing upgrade. It is done. Like our one is done.
Oh,
No, it's not completely
what
done.
about
Hold on.
what
You don't.
about? Okay.
So this is like control plane, which AWS manages. Okay. Now we will do node group. So there are two. One is control plane, one is node group. So control plane is done. Now we'll go to node groups. So now, how do you do node group upgrade? So there are two things. The existing, we have two nodes running. If you see here, we have two nodes running. Okay. You see, we have two nodes running, and it is with version 1.21. I cannot do it. How do I do it? I have to terminate this everything. So for that, what I've done here is, if you see, I've done one more thing. What I've done here is, see, what I've done here is, I have added one more node group here. Okay. So the plan is, we'll create one more node group with a different name. So I've created my node group ng new. So previous one is my ng. Second one is my ng new. Okay. And here we should keep two desired because currently we have two, right? Currently, if you see, we have two pods, two nodes running. So if I don't give two, what will happen? The existing pod, it will crash and you will have a service downtime. So I don't want that. So for that, what I'm doing here is I will start new node group also two, and then I will stop the previous node group, old node group, so that all the nodes will get migrated to the new one, all the service, and we'll see if you get any downtime there. Okay, we'll see. Maybe see 1 minute downtime is anyone can afford, but anyway, we can do that. We can manage that as well with some other, there are other settings like, affinity and like pod distribution budget, all sort of things are there. So what I'm going to do here is etctl create node group. I'm creating a new node group. So if you see here for now, if you go to cluster again, if you go to cluster, you see here there's only one node group. See here, there's one node group. Okay, my node group. I'm going to create a new one. A new node group will be created in 1.22 version. Fine. So currently, if you see, it is 1.221, but new is getting created with 1.22 because our control plane is already updated. Okay, our control plane is already updated. See here, this is already updated with 1.22 version. Now I'm creating a new node group. See, our downtime, there is no downtime. It's running. Your service is running. Your pods are running. There is no, but I'm creating a new node group, and then we'll delete this old node group. And what it will do, it will automatically takes all the pod from old node group 1.21 to 1.22. We'll see it in demo. There is one note here. Okay, it's creating a new node group with version 1.22. It will create 2 nodes. So if you keep on checking here, say, let me watch -1, kubectl, create nodes. We should see new node coming in some time with version 1.22. Okay, so our pods are running, no disturbance. Our cluster, our end user is able to access it. Let's assume it's end user. I know it's not, but yeah, let's assume it. Our cluster, like I'm creating new node group. Able to access, running, node, we'll see, and then we'll see it here. So what I'm doing here is, as a part of this upgrade, I'm adding one more node group, right? And then that node group will come in 1.22, and then I will move all the traffic, like all the existing things. I'll take off the old nodes, and if I take off, I'll if I disable scheduling there, it automatically pulls everything and put it to the new nodes. Let's see it. So this upgrade process takes bit time. Even I cannot help there. This is what it takes, and moreover, we're doing all live. See, our applications are running. This is very important thing. We are doing everything live. If we go here to clusters, we should see in some time one more node group is getting added here. See here. Okay, earlier it was 2, 1. Now we have got these 2 nodes. It is version 1.22. Okay, so this is the difference. We can see it here in the console, but anyway, we'll see it here, and we'll see it in here as well. See, it came in new node 1.22. So we have got 4, right? 4 seconds ago, 24 seconds ago, version this, version this. This is ready. This is ready. Fine. So let it come ready, then we'll do next step. So this is running. This is running. Once this is done, then we'll go to other steps. Yeah, this is ready. So let's wait for this to finish. So there's one more. There's one thing. There's one note here. Yeah, this is done. Okay. One note here. So when this cluster autoscaler, right? This policy we have to attach to the new node group as well. So for that, what I have to do here is I have to go to cluster autoscaler, CA policy, and here I have to attach it to my new node group. And I have to detach from my previous node group because we are going to take it offline. If I don't reattach, what will happen is it will not let me delete between. It will always says it is attached. You cannot delete the cluster. So that is what I am reattaching the cluster autoscale policy, which was attached earlier. I'm detaching that. So these are a part of, again, I have did some automation around that just to save our time. Okay, so that is done. Now what I have to do is, what we have done update cluster. We create a new node group, right? We have detached the policy from the old node group. Now we have attached to the new node group, and now there are a couple of things. So we have to update these cube proxy cube all things these as well. So let's do one by one. So if I do this util proxy update, take a look here. We should not get any disturbance during this entire process. It should go on and on and on. We have got 4 cluster 4 server running. Sorry. Let's check the cluster name, guys, because my cluster name is different. Okay. So queue proxy is updated. And the next thing is AWS node group you have to update. And the third thing is you have to do this. And we should not see any disturbance here again, as I said. This is all we are doing live. Okay. Everything is live. We have 4 nodes running. Okay. So our cluster is up to date. So what I'll do now here is I will remove the old thing, which I don't need. So, okay. I'm removing the old node group. So what I have to do here is, this was my old node. So I'm just removing entry out of it. This can be done from the command line, but I'm just showing you. Why? Because I just want to have a record of everything. So this is my old node is deleted from the configuration. Now I have to delete from the actual configuration from the cloud as well, right? So what I have to do, there is command for this. So delete node group hyphen of this only missing approve. So whatever missing from that configuration, it will do. Okay. So the file is EKS cluster.yml only approve. Let's see this now. This part is very important. We might see 1 second of downtime, and we'll see these all will get created. Okay, so this is very important. And take a look at here. This will go the old node. This node will go unscheduled, not ready, something like that. Let's see. See, it's removing, right? Let's see here. See, it's going schedule disable. Okay, old nodes. See here, it's getting created. We might see a bit of flip here for the end user. See here, there's a flip. We can control this whole thing, as I did not do much setting here. See, there's a flip. Okay, again we are back. So it's 2 second downtime, which is okay, but again we can control that, right? So it's cordon. It's cordon. We have got again, see, it's newly created 4 second, 4 second, 4 second. It is in new servers. Okay, this 38 seconds. We had only 2 seconds blip here, and we did all the upgrade without any downtime. Okay, it is done. In some time, this will get deleted. So we'll have only 2. Okay, so now it will get deleted. So we'll see it. Now, if I say cube version hyphen short, we have 1.22. So our cluster is completely upgraded without any downtime, like 2 second downtime, which is okay, which again I'm saying we can control that as well. So with this, our demo is done, or our session is like almost end. So I'm open for any question now.
Hello.
Yes.
Hi, Shubham. So the after upgrade, we 21 to 22. Can you please repeat one more time what you did? Actually, I missed it last 4 minutes. How you moved that their services, everything to.
No. So what I did was I have upgraded the cluster. There's a command. Okay. And after that, I have created a node group, new node group. So when you create a new node group, it comes with the version, latest version as of control plane version. It comes in 1.22, but my pods were still running in old node group, right? So what I did was ekctl has a command. If you remove the previous node group, it firstly take it to unscheduled mode. So the moment it goes to unscheduled mode, all the pods will get evicted and it will get pushed to the new node, which is there with 1.22, and then that's get deleted. Okay, and during that process, there was a 2 minutes, 2 second blip we had, like there was something, and then we had the entire thing running again, like 324 2 minutes ago. And to follow along, I mean, there are other commands as well which I followed from my notes here. You can just follow along. We have given all the notes if you really need it. And then finally we have this version, upgraded Kubernetes version. So now if I go to console, right, and see the version here in the console, I should see here there's no update, it's 1.22. So with this we can say from 1.21 without any downtime, with all the service running, with end user accessing, we have upgraded to the 1.22. Yes, anyone has any doubts? I know
Okay.
we ran out of time, but still I think that should be fine. Anyone else has any question? No one?
Yeah, I have one question.
Sure.
Sorry. So so we upgraded the we node we have added.